Hello, everyone. A very warm welcome to everyone present in this live session. So, I am Anjana Sharma from Telcoma Technologies. So, today I am going to discuss about the 5G new radio technology. So, let's start. What is 5G new radio and what are the differences with the LTE radio systems? So, this is 5G new radio training. So, in this live session, we are going to discuss about the 5G new radio concepts. So 5G new radio is basically a 3GPP new 3GPP global standard, which is being developed so that it can cover up or it can be used in the air interface of the 5G technology. So the name given to it, the name given to this air interface as a new radio air interface. So let's discuss about the explanation of all the 3GPP standards and the new radio timeline. So new radio is basically a new radio access technology. As I told you that it is being developed, it is developed by 3GPP for the 5G mobile network. Now this was designed as a global standard for each and every operator and for countries. Now what it utilizes? It utilizes the modulation, it utilizes the new waveform, access technologies, and all that will enable the system so that they can meet all the needs of the high data rate services, low latency and high reliability services as promised by the 5G technology. The 5G technology has promised that the new technology from the 4G that we are going to give you the enhanced mobile broadband, ultra reliable low latency communication and massive internet of things. That means you will be able to connect the massive number of devices together. So in order to meet all the promises that are given by the 5G technology, so we require to develop the air interface that should be new from the previous generation. So the new air interface is named as the new radio air interface or the new radio technology. So this is interface is built on the established technology. So why it is built on the established technology? So that there should be both backward as well as the forward compatibility. From the backward compatibility, we call it as like 4G technologies. That means this should be capable to handle all the 4G traffic also as well as the forward compatibility. That means as we are moving towards the 6G technology, so this will be able to handle that also. So backward as well as the forward compatibility. Now with all the new levels of latency, new levels of reliability, there are new levels of security. This 5G new radio, this will scale efficiently. That means the air interface should be scalable enough so that it can scale to connect the massive number of devices together. We call it as massive internet of thing, and this will offer you the new types of the mission critical services also. Now, all these standards, which are called as new radio standards, these are published in release 15 specifications. And these are further developed. That means in release 16, 17, 18, these are further developed so that it can include all the new features. This can include new functions, new services, etc. Now, this new radio, this will define the air interface. That means the air interface should be defined in such a way that it will support all the next generation community services also. So this should be able. That means new radio should be able to have both the mode. It could support both mode. That means it could support the standalone and it could support the non-standalone mode also. Now, what is this standalone and non-standalone? See, the deployment of the 5G is always in two modes. Either you can deploy the 5G network in standalone mode or you can deploy in a non-standalone mode. Now, what is the difference between the two? That means in standalone mode, there is a fully established 5G network. There is no dependency on the previous networks. We call it as standalone mode. That means all control plane, user plane is handled by the new radio cell. Whereas in non-standalone mode, there is a dependency on your LT cell, that means the 4G network. So all the control plane functionality is handled by the LT cells. So we call it as non-standalone. So there is a difference. That means this standard that you are developing for the 5G technology should be able to handle the both. That means your standalone as well as your non-standalone. Again, as it is covered by me, in non-standalone, the new radio cell will use the LT cell as a control plane anchor, whereas in standalone, the new radio will have new radio cell will have full control plane functionality. It has the multiple use cases. The multiple use cases include the enhanced mobile broadband, mission critical control services, massive connected devices with the ultra high reliability. This have low latency communication in frequencies above and below 6 gigahertz of the range. Now, what is this above and below 6 gigahertz? We will cover up in our spectrum class, spectrum of this. Now, the different new radio applications, like we have new radio and its applications are categorized. Like we have mission critical control, we have massive IoT, and we have enhanced mobile broadband. The mission critical control will have the strong security. It has ultra high reliability, ultra high extreme user mobility. We call it as mission critical control. Then enhanced mobile broadband, we can give extreme capacity, ultra low complexity, deep awareness. Then in massive internet of things, we have deep coverage, ultra low energy, ultra low complexity, and high density. So this is the timeline. We can see that how it is corresponding release 15, release 16, 17, etc. Now, what are the new radio technology enablers? That means what are the technical things that are into this air interface, and with that you will be able to have that much of data speed and ultra high reliability and low latency. So they are going to use optimized OFDM based waveforms and multiple access in this. So optimized OFDM based waveforms and multiple access are used in this. There is a scalable OFDM numerology with the scaling of subcarrier spacing. We are not going to use the fixed numerology for subcarrier spacing. There is a scalable because it has to accommodate the massive number of devices together. So this is scalable. You can scale up as per your demand. Then 3D beamforming is also there. There is a new radio access network architecture, massive multiple input and multiple output. Then we have advanced spectrum sharing techniques there. Then concept of wave radios. There is a concept of network slicing and the denser radio deployment. Moving to the next, now let's discuss about what are the benefits of the 5G new radio. So we have the larger wireless area capacity with this. That means the capacity is very large. There is an increased energy savings. Then there is a lower period of time between the updates. Like you are having updates, so lower period of times and average service creation time is also less. Then there is a improved links that can connect the larger number of users together. There is an improved technology for maintaining the quality of connection over a complete or a broader geographical area. There are enhanced speeds and data rates is also there. Improved efficiency in the data sharing. Now, this will be able to deliver a huge number of services which are provided across a different set of devices. And it also supports the wider range of deployment models, like from traditional macro model to the hotspot deployment. So the new radio will offer all the new ways for devices, like how they can interconnect, like device to device and multi-hop. This is a part of wider or flexible network architecture. Now, a new radio is designed in such a way so that it can improve the performance, scalability, flexibility, and efficiency also. And this will be able to use most of the spectrum, either licensed, unlicensed, shared. It should be able to use the spectrum. Now, 5G will make use of licensed, unlicensed, and shared spectrum also, because it has to meet all the demands of the 5G. So it has lower band, mid band, and high band. Through the picture, we will try to understand like this. This is a lower band, which is frequency range 1, then mid band, frequency range 1, and high band, frequency range 2. The frequency range is divided into two categories, frequency range 1 and frequency range 2. Frequency range 1 has your low band and frequency range 2 has your high band or mmwave band, which is in gigahertz of the ranges. Low band will give you the 450 megahertz to 1 gigahertz. The mid band will give you 1 gigahertz to 7 gigahertz and high band 24 gigahertz to 52 gigahertz. If you want in a broader geographical area very good coverage, but throughput is not there as a major parameter, so you can give a lower band because this will give you a good coverage and throughput will be comparatively less. 5G, 4G, 3G, 2G, everything will be accommodated in this. Mid band will give you a mix of coverage and throughput. So 1 gigahertz to 7 gigahertz. So 5G, 4G, 3G and 2G will be supported. And high band, which is 24 gigahertz to 52 gigahertz, and this is completely wave band, coverage will be less and throughput will be very high, only 5G technology. That means we can say that we can give this frequencies to the private networks. We can create our own private network where throughput demand is very less. You have to connect the number of devices together. Throughput demand is more. Coverage is not a parameter here, so you can give yes. And a previous slide I told you like below 6 gigahertz and above 6 gigahertz. So this is below 6 gigahertz and this is above 6 gigahertz. So the lower band spectrum, by using a wider bandwidth and advanced antenna technology, this will enable all the services. Now there is a concept of DSS. DSS as a dynamic spectrum sharing. This will enable an operator so that it can run 5G in already existing 4G spectrum. So the technology is known as DSS as a dynamic spectrum sharing. The amount of cell that is used in 4G and 5G changes dynamically and that's totally depends upon the requirement. The 5G technology and spectrum allocation is very important for the industrial IoT development and its uses. So bringing 5G to such areas, we can have a gain in productivity, economic growth, and other benefits also. So now the private networks that we are creating that can use the licensed, unlicensed, dedicated, and shared spectrum also. Now sub 6 gigahertz, which is a frequency range, it can give you a good mixture of coverage and capacity. While wave spectrum, that is, it will give you wider bandwidth needed for ultra high throughput and ultra low latency requirements. So frequency range 1 are below 6 gigahertz and FR2 include your high bandwidth and wave. So we have different spectrum, like we have licensed spectrum. This is exclusive use. Over 40 bands globally for LT. So this will always remains the industry's top priority. Shared spectrum. Shared spectrum is a new spectrum sharing technique. 3.5 gigahertz, 3.7 gigahertz, etc. Then unlicensed spectrum 5 gigahertz, 6 gigahertz, 60 gigahertz. This is global. And we can unlock more spectrum globally. We have new markets and verticals and new development scenarios. This is to be covered in live session today. In our next live session, we are going to discuss about the 5G new radio deployment scenarios. So that will be covered in a live session tomorrow at Telcoma. Thank you so much.